Okay, I think one of the best ways of doing these problems is to draw yourself a little picture. So here you go. Here goes Eric. I've got a bowling ball dropped out of an airplane. So let's see. Here's my airplane. That's a great airplane. And let's see how fast it's traveling. 156 meters per second this way. Alright, that's a terrible arrow. And let's see. The bowling ball is dropped directly over the bowling alley. So here's the bowling alley. Here's the bowling ball, okay, and the bowling ball is going to hit the ground over here, and it's going to hit 23.5 seconds later. 23.5 seconds. And here are the questions I've been asked. Okay, how far away from the bowling alley? Now that's a horizontal distance. So I'm looking for a distance that is horizontal. And the thing to remember is we have certain equations we're going to use. Here are our equations. We're going to have V equals d over t. This is what we're going to use for horizontal motion. Now I'll use blue for the other ones. We have A equals delta V over t. We'll use that when we want to find how fast something is going vertically, or when we know that. And we're going to use d equals 1/2 at squared. Say what? That's if I know a vertical distance. So the blue ones here that have acceleration in them are for things that are moving in a vertical direction. And this one here that doesn't have an A in it is for things traveling horizontally. The bowling ball, as it travels horizontally, does not accelerate because we're ignoring friction, but it does accelerate in the vertical direction. So with that in mind, let's try this. How far away? So what I need to do, I need to use this equation to answer that. So I know the bowling ball is traveling 156 meters per second equals the distance I'm looking for divided by the time it was in the air, and it was in the air for 23.5 seconds. So that means I'm going to multiply those two together, and that gives me 3,670 meters equals the distance. Now, how high was the airplane flying? That's a vertical distance. So for vertical distances, I have to use d equals 1/2 at squared. I'm looking for the distance. That's how high it was. So the distance equals half the acceleration. Since the acceleration is 10, half of that is 5, times the time it fell for, which is 23.5 squared. Therefore, the distance is going to equal, the vertical distance is 2,760 meters high. Now that one was just straightforward. We didn't have to, there were no two-stick problems there. Let's move up and try another one here. I'm going to make this a little bit larger, okay. Careful this one. An arrow is fired straight up. So here you go. We have an arrow fired straight up. There it is. I'll put little fletchings on it. Look, I knew the word for the feathers. They're called fletching. All right, I watched. I'm too much of a fantasy nerd. Okay, here you go. 35 meters per second is an upward velocity. But remember, it's going to be subject to a 10 meter per second acceleration because this is vertical. So the question now is, how long will it continue to climb upwards? So I'm looking for time. What I have is a vertical velocity value right here. And so when I've got vertical velocities, if you recall, for vertical velocities, the equation to use is this one here. This has velocity, and this is vertical because it's got acceleration. If I want velocity for something that's not accelerating, I'd use this one. But here's the one I've got to use. The whole trick to this, people, is to figure out, is it accelerated motion or not? And for our ballistics problem, the vertical component is accelerated. So, therefore, I have to use this equation. Acceleration equals the change in velocity over time. Now, I know the acceleration is 10 meters per second, and I know the starting velocity, the vertical velocity, was 35 meters per second. So to solve for t, I'm just going to swap these two with each other. So I'm going to say 35 divided by 10, and what that gives me is it's going to climb upwards for 3 3.5 seconds. Now, how high will it climb? High is a vertical distance. So since this is a vertical value, I have to use an equation that it takes into account acceleration, and that's going to be d equals 1/2 at squared. And so therefore d, the distance upwards, is going to equal half of a. Since a is 10, half of that is 5. The time I now know is 3.5 seconds, and I'm going to square that. So therefore, the height it climbs, the distance up it climbs, will be 61 meters. Now, how fast will it be going when it hits the ground? That is a velocity, and on its way down is a vertical velocity. And here's what's something that sometimes just takes students by surprise. It's very symmetrical. So if you think about it, the arrow goes up and the arrow comes down. However fast it was going when it went up is how fast it's going to be going when it comes down. So therefore, if it went up at 35 meters per second, it's going to be coming down at 35 meters per second when it reaches the ground, assuming that it's, you know, where the ground is where it was launched from. I know that's not quite right. Now, or you could do it the other way if you wanted to. You could use this equation right here. You could say, well, I want to know how fast. The time is 3.5, so I'll put that here, and the acceleration is 10. 10 times 3.5 is 35. But the easiest thing to say is, you know what? However fast I launch up, that's how fast it comes back down. It's very symmetrical that way. Alright, now this next one has an angle value, and that's when we have to use sines and cosines to solve them. So what we have here is a bullet being fired at an angle. So here's my bullet. And the angle is, this angle is 73 degrees above the horizontal, and the velocity that it's being fired at is 235 meters per second. But some of that is directed horizontally, and some of that is vertical. And the way to tell them apart is the horizontal is going to be the cosine of the angle, and the sine of the angle will give me the vertical. Let me first, but before this works, you've got to make sure you're in degrees and not radians. Let me insert a little video that's going to show you how to do that. Okay, so if you play this video, which I think you can do by hitting a button, it's going to show you how to take this, and basically what you're going to do is you're going to hit the mode button, and that's going to bring up a screen here, and you're going to scroll down using these buttons until you take it from radians, which will be blinking, and then you toggle over until degrees are blinking, and then you hit enter and clear, and it works. So once I do that, if I want to find the vertical component of motion, to find the vertical, you use the sine function. So I take the sine of 73, and if you're in radians, it doesn't work, but if you're in degrees, it does. So what I do is I take the velocity, which is 235 meters per second, and I multiply that by the sine of 73. And when I do that, what I'll find is that the vertical velocity is actually about 225 meters per second. So of that 235, 225 is directed upwards. Well, it's a pretty steep angle, so that shouldn't be too surprising. How long does it climb upwards? So I'm looking for time. So how long is time? And this is in a vertical direction, so I have to see what information I have. Now, all of my equations have time in it, but what I know is the vertical velocity. So since I know the vertical velocity, I'm going to use the equation acceleration equals the change in velocity over time. I know it accelerates at 10. I know that the vertical component of velocity was 225. I got that up here. And I'm going to divide that by time. Now in order to do that, I swap these two, right? That's how I solve for variable in the denominator. So 225 divided by 10. Correct me if I'm wrong, but I believe that equals, let's say t equals 22.5 seconds. How long will it be until it hits the ground? Well, if it goes up for 22.5 seconds, and then it's going to have to come down for 22.5 seconds. So that's going to put in the air for 45 seconds. Which is basically, I get that by taking this here and multiplying it by 2. Alright, that was fun. Let's try the next one here. Alright. Oh, wait, that didn't work. So here's what I've got. I have a table. I have a ball rolling across the table. I have a bucket over here on the ground. Now the table is from here to here is 1.8 meters, and from the edge of the table to the center of the bucket is 3.1 meters. Now let's see what we've got. First question, how long will it be in the air? Now how long is time? And how long it's in the air has nothing to do with horizontal velocity. No matter how fast I move it this way, what determines how long it's going to be in the air is how far it gets to fall. Remember, how long it's in the air is always a function of vertical components. So I'm going to have to use, this is meters, so it looks like it's back to my old favorite, D equals 1/2 AT squared. Say what? So distance is 1.8 equals half of A is 5 times T squared. So that means what I'm going to have to do is divide both sides by 5. This then cancels out. But what I have here is T squared. I don't want T squared, so I take the square root of both sides. And what that will give me is T equals the square root of 1.8 divided by 5. And that is 0.6 seconds. So it's 0.6 seconds it's going to be in the air. Now the next question is, how fast will it need to be rolled? Now that is a horizontal velocity. It's rolling horizontally. And remember, for horizontal motion, I use this equation. V equals D over T. And I have to use that because there's no acceleration in the vertical direction. I mean, in the horizontal direction. So horizontal motion does not have acceleration. We're going to assume there's no friction. So we just want to know how fast I have to go this way in order to fall here in 0.6 seconds. So I'm solving for V. That's how fast. The horizontal distance, since this is a horizontal problem, is 3.1 meters, and the time it's in the air is 0.6 seconds. So therefore, the speed it needs to be rolled, the velocity it needs to be rolled, is 5.2, what says it, 5.2 meters per second horizontally. That's what it needs. Welcome to the back side of your paper. Let's draw a picture of this one. I have an airplane. There's my airplane. It's a terrible airplane. It is flying horizontally at 235 meters per second. It drops a water balloon, and that water balloon is going to travel this way, and it's going to hit a target over here, which is a distance of 845 meters away. So the first question I'm asked is, how high is the airplane? Now remember, how high is a vertical distance, and when you're solving vertical values, you have to have acceleration. So that means I need an acceleration distance. That's going to be this equation here. D equals 1/2 AT squared. So that means I have to say half of A is 5 times T squared, and unfortunately I don't know what the T is. Darn it, I'm going to have to figure out what that is. Where am I going to get that information? Well, I have some horizontal values here. I know that the airplane is traveling horizontally at 235 meters per second, and the balloon travels a horizontal distance of 845. Now remember, when we're solving for horizontal values, you have to use the equation V equals D over T. That is the one equation that has an object traveling at constant velocity. And for our ballistic problems, we will assume there's no friction, and therefore objects travel at a constant horizontal value. Now, they accelerate as they fall vertically, but they travel horizontally at a constant velocity. So we'll use this equation for that. So let's see what we've got here. We've got a velocity of 235 meters per second. We have a distance of 845 meters divided by the time we want to know. So anytime I'm solving for variable in the denominator, I swap these two values. So that gives me is a time value. In this case, the time is 3.59 seconds. 3.59 seconds is how long it will be in the air. I then take this time value, as I do in most of these ballistics problems, and put it over here. So what I end up with is the distance is actually going to equal 5 times 3.59 squared, and therefore the distance, the vertical distance, the height of the airplane, is going to be 64.6 meters. Cool. Let's try next one. I have a punter kicking a ball. The ball, I'm not going to draw the punter because I would if I was doing it on a regular piece of paper, but it's hard to draw it. Okay, here I go. Here's a punter kicking a ball, and the ball has, here's the ball, and it has a vertical velocity of 28 meters per second. And we want the ball to land a horizontal distance away that is equal to 87 meters. Cool. Now what we got? The question is, how much horizontal velocity? Well, to find the horizontal velocity, I have to use the horizontal motion equation, which is v equals d over t. I need to solve it for v. Well, that means v equals the horizontal distance is 87 meters divided by time. There we go again. I don't know what the time is. Darn it. Well, I happen to have some vertical motion I can turn to. I know it has a vertical component of velocity of 28 meters per second. Now, meters per second is velocity. So I have to have a vertical equation that has acceleration and has velocity. And that equation, of course, is A equals delta V over T. So I know that acceleration is 10. I know it started off at 28 meters per second. That's my vertical velocity, and I need to solve it for time. So I'm just going to swap these two with each other, and then that gives me 28 divided by 10 equals the time. That's 2.8 seconds. But remember, that's how long it travels up for. It doesn't just go up, it's also got to come back down. So I have to double this value here. So when I double 2.8 seconds, that's going to give me 5.6 seconds. So the ball is in the air for 5.6 seconds. I then take this value and substitute it in right over here. So what I'm going to say is the velocity, the horizontal velocity, is going to equal 87 meters divided by 5.6 seconds. And that's going to give me a velocity then of 15.5 meters per second is the horizontal velocity that the ball is going to have. Okay, got to draw this one. I got Bobo the Clown shot out of a cannon. Boom. Let's see. Now, he comes out of the cannon at 17 meters per second. Some of that is oriented vertically and some of it is oriented horizontally. How am I to find out? I'm going to use the angle here of 25 degrees. That's how much above horizontal he was fired. So I can use that by using sines and cosines. I can figure out what the horizontal and vertical velocity is. So I'll have to decide when by looking at the questions I'm asked. The first question I'm asked is, how long will Bobo be in the air? That's a time. And remember, the time you're in the air is a question of your vertical motion, not your horizontal. So therefore, what I need to find is, what is the vertical component of Bobo's motion? To find the vertical, I'll take the sine of the angle. So to solve this, what I'm going to say is, take his velocity, comes out at 17 meters per second, and I'm going to multiply that by the sine, which is what I use for vertical motion, the sine of 25 degrees. And once again, make sure you're in degrees, not radians. And if I say 17 times the sine of that, that gives me a vertical velocity of, well, doggone it, that gives me a vertical velocity of 7.18 meters per second. Okay, but that's not how long he's in the air, that's how fast he's going vertically. So what I have to do now is I say, okay, I have a vertical velocity, and I know that acceleration equals the change in velocity over time. I know he's accelerating at 10 meters per second. I now know his vertical velocity is 7.18 meters per second, and I want to know the time. So I swap these two. So when I divide 7.18 by 10, what I get is Bobo is going to go upwards for 0.718 seconds, and then he's going to come down for the same amount of time. So I have to double that. So I have to say 0.718 times 2, and that puts him in the air for 1.4 seconds. Oh, Bentley. Here, I gotta go let my dog in. He's barking. Alright, the next question is, how high will Bobo go? Now, that's a vertical distance. Now, you've got to be careful with these because how long he's in the air takes into account both going up and coming down. But think about it. Bobo is at his maximum height halfway through the trip at 0.718 seconds. Hey, Bentley. So I'm going to use d equals 1/2 at squared to find the vertical distance. So d is going to equal 1/2 of a, which is 5. And the time value I'm going to use is 0.718 squared, because that's how long he was going up for. And when I do that, what I get is that he goes a whopping 2.6 meters. And our next question is, how far away will Bobo land? Now, far away, generally in these questions, is going to be a horizontal distance. So to solve a horizontal value, I say v equals d over t. That is my horizontal equation. And I'm looking for how far away. How far away is the distance part of this. So I have to know it with a horizontal velocity, and I have to know the time he's in the air for. Well, I don't know his horizontal velocity, so I'm going to have to find it using this information up here. So what I have to say then is, okay, to find the horizontal velocity, I'm going to say, well, I'm going to say the horizontal velocity is going to equal 17 meters per second, which is how fast he was shot out of the cannon. In this case, times the cosine of, and let's see, the angle is 25, so 25 degrees. So 17 times the cosine of 25 degrees. Let's see, where is that information? Where is that? Oh yeah, that's 15.4 meters per second. 15.4 meters per second. And I'm going to take that value right here and put it over here. So I'm going to say 15.4, the horizontal component of his motion, equals the horizontal distance I'm looking for, divided by, in this case, if you think about it, Bobo is going to be traveling horizontally the whole time he's in there, not just on the way up, but also on the way down. So instead of using this value, I'll use this one right here, because he's traveling horizontally for all of that time. So that's 1.4 seconds. Now, to solve for d, I have to multiply both sides by 1.4. So distance is going to equal 15.4 times 1.4, and therefore the distance in this case is going to equal 22 meters away. Go Bobo. Let's move this on up. I have a bomber. That's an airplane, in case you don't know. Here it is. It's flying at 220 meters per second, horizontally, we will assume. The altitude of said airplane is 5,100 meters. And the question is, how far ahead of its target? That's going to be a horizontal distance I'm looking for. So to solve that problem, I'm going to say v equals d over t. I bet you Mr. Sampson didn't give you the t. That seems to be his modus operandi. Alright, so I want to know how far ahead of his target. So what I want to know is, how far ahead of target do I have to let go of that bomb in order to hit that target? That's a hard thing to do. No wonder it was hard to hit targets back in the old days of World War II. So let's see. In order to know that, I have to know the horizontal. I have to know the horizontal velocity, which I do. Horizontal velocity is 220 meters per second. I'm looking for d. Yep, there you go. I have to know what the time is. And Mr. Sampson didn't tell me. but I do know how high it is, so therefore I can get that by using our old friend d equals 1/2 at squared. So I know the distance is 5,100 equals half of a is 5 times t squared. So I have to divide. So really how I'm going to solve that is I'm going to, I'm going to have to just move down here if you don't mind. I'm going to say, why do I keep doing that? 5,100 divided by 5 equals t squared. So I had to take the square root of both sides. So when I do that, when I take the square root of that, I find that bomb is falling for an amazing 31.9 seconds. So now I take that value like I've been doing, take that time value, and I put it in over here. 31.9 seconds. Now to solve for D, I'm going to have to multiply 220 by 31.9, and that's going to give me a distance of 7,030 meters ahead of target. Think about that. 7 kilometers ahead of the target is where you let go of it. That's pretty amazing. Well, let's go on to the next one. Oh, another punter. Okay, so I have a punter who kicks a football. And it has a hang time of 5.3 seconds. That means the total time it's in the air is 5.3 seconds. If the ball lands 65 meters away, so from here to here is 65 meters, let's look at the different questions I've been asked. What is the vertical component of velocity? So in order to find the vertical component, I have to use this equation. I have to either use d equals 1/2 at squared or a equals v over t. Well, what information do I have that will help me? Well, I know how long it was in the air, right? So I'm thinking the way to solve this would be, and I know what the acceleration of gravity is, so I can do this. I can say the acceleration equals delta v over t. And I know that basically what I know is that it came off his foot with a certain velocity, and that velocity reaches 0 at this point here. Halfway through the trip, its vertical velocity was 0. So what I had to do is I had to take 5.3, which is the total hang time, and I got to divide that in half. So half of 5.3 is 2.65. So I'm going to have to say acceleration is 10, the time is 2.65, which is half the hang time, and that's going to give me the change in velocity. Now to solve this, I have to multiply both sides. So what I find is it must have come off his foot with a vertical velocity of 26.5 meters per second, because it went from there to 0 in 2.65 seconds. Now, what is the horizontal component of motion? Well, that means I need to use horizontal values. I have to use this equation here, v equals d over t. So to solve that, I have to know the horizontal distance, which I do, 65 meters. Now, this time, keep in mind that the whole time it's in the air, it is traveling horizontally at a set velocity. So in this case, I have to use the entire time. So that's the tricky thing about these up-down problems. The vertical velocity goes to 0 at the apex. The horizontal velocity stays the same the whole way across. So I have to use the whole time of 5.3 seconds. So 65 divided by 5.3 gives me a horizontal velocity of 12.26 meters per second. Sorry, I'm not doing a very good job with my significant figures there. I should just say 12 meters per second. And then I'm asked, how high does it go? Well, that's a vertical distance, so I have to use d equals 1/2 at squared. I'm looking for d. D is going to equal a half of a. Half of a is 5. Now, what time do I use? Well, remember, where does it reach its maximum height? It reaches its maximum height halfway through. So don't use the whole time, use half the time. So I'm going to say times for t squared, I'm going to say 2.65 squared. Therefore, the distance is going to equal a whopping 35 meters up is how high that ball went. Nice job, Punter. All right, let's do our last one now. All right, we have a stunt woman who wants to film a scene where she drives a motorcycle off a... Oh, I love these problems. You know I love these problems. So here's my cliff. Okay. The height of the cliff is 36.5 meters. This is like the ball off the table. Okay. She would prefer to miss the rocks at the bottom of the cliff and land on a cushion on a barge which is anchored 111 meters away. There's going to be a barge with cushions on it. And that's 111 meters away. And that's all the information I have, other than we assume she's on Earth where the gravity is 10 meters per second. So, how much time will she have between flying off the edge of the cliff and knowing if she pulled off the stunt successfully? Well, remember, how long you're in the air is not a function of horizontal motion. It is always a function of vertical motion, either vertical velocity or vertical distance. In this case, it's vertical distance. So to solve this problem, I'm going to say d equals 1/2 at squared. The distance is 36.5 equals half of 10 is 5 times t squared. So what I have to do then is I have to say 36.5 divided by 5 equals t squared, but I don't want to know what t squared is, so I have to take the square root of both of them. And when I take the square root of that, that's going to give me 2.7 seconds. 2.7 seconds is how long it's going to take her to get from here to here, or at least from here to here. Hopefully she'll end up over here. Now the whole time she's in the air, for all 2.7 seconds, she's going to travel this way at a constant rate. Remember, she accelerates this way, but travels this way at a constant velocity. So, the next question, and the last question on your homework, is how fast, which is velocity, does she need to be going when she leaves the edge of the cliff? That is going to be a horizontal velocity. So to solve that, I have to say v equals d over t. That's my horizontal equation. Now, the horizontal distance that we need to achieve is 111 meters. So that's going to go here, 111. And how long is she in the air for? She's in the air for 2.7 seconds. And 111 divided by 2.7 is going to give me 41.11. We'll just call it 41 meters per second. She goes off that cliff at 41 meters per second and falls for 2.7 seconds. She has pulled that stunt off successfully, just like you pulled off a successful homework assignment, I hope. Catch you next time.